Hello students, in my last video I have discussed the problem of a particle sliding on a plane, inclined plane or wedge using Newtonian mechanics techniques. So in this video I am going to solve the same problem using Lagrangian method. So let us see how to approach this problem using Lagrangian mechanics. So let me say this angle is theta, and let me define my coordinate axis like this. This is my x-axis, this is my y-axis. Let me take this as the origin. So if I write the xy coordinate of this particle, I can say this is my x, this is my y. If I say the total length is L, then I can write the constraint equation tan theta is equal to y by L minus, this distance will be L minus x, L minus x. Now, if I differentiate this equation, this constant equation, which gives the relation between x and y, and if I differentiate with respect to time, so say this is my y, L minus x, tan theta. So this will give me y dot equal to minus x dot tan theta. Here, theta is not a function of time, theta is not varying. So similarly, I can write y double dot is equal to minus x double dot tan theta. That means y double dot is nothing, is the acceleration in the y direction is equal to acceleration in the x direction into tan theta. So I say this is my equation number one. This is a constant equation. Now, let us write the Lagrangian function for this problem. So Lagrangian is given by potential energy minus kinetic energy minus potential energy. And so here I can write L is equal to half m x dot is square, y dot is square, motion in the plane, but there is a one constant equation, so there will be only one degree of freedom. So we have to write only one Lagrangian equation. So this will be minus potential energy. Potential energy is particle is sliding because of gravity. And I say if this is the y is here at this plane, if potential energy is zero, so I can write the potential energy here. Here it will be mgy. Now let me put the values of x dot and y dot. So L is equal to half m x dot square, y dot I can write from this equation will give me x dot square tan square theta, and this is m g, y is nothing, L minus x, y L minus x tan theta. Now let me write the Euler-Lagrange equation. Del upon del x dat d by dt minus del upon del x is equals to 0. So if I find del L upon del x dat x dot, so this will give me, here I can write the Lagrangian is like this, half m x dot square sec square theta minus mg L minus x tan theta. So this gives me, if I differentiate this one, this gives me m x dot sec square theta. And if I differentiate this with respect to time, d by dt, this gives me m double dot x sec square theta. Now let me write del L by del x. So del L by del x give me here this minus minus plus. So this will give me mg tan of theta. Okay, now put these values in the equation and I can write the equation of motion. So this will be d by dt, its value is m x double dot sec square theta, which is equal to mg tan theta. And if this will be cancel, if I solve, this gives me x double dot, which is equal to x component acceleration. This comes out g. If I solve this one, this gives me g sine theta cos theta. Now, similarly, now I can find the ay also, putting the value here. So the value of y dot or ay will be minus ax g sine theta. Okay, cos theta, tan theta is sin theta by cos theta is cancelled. So this will come g sine square theta. So now I have both x component and a y component. So I can find the acceleration. So acceleration is in this direction. So this component is ax is basically a cos theta, and this is a minus a sine theta. So from here I can find the value of ax, value of a is g sine theta, or I can calculate the magnitude. A is equal to ax square plus ay square, and this gives me g sine theta. So g sine theta is the magnitude, total acceleration. This is the x component, and this I can write minus g sine theta, and sine theta. This is the y component for this problem. Okay, so we have calculated now the total acceleration with respect to the wedges not moving. Okay, so we can consider as an inertial frame. So with respect to the wedge, the acceleration of the block is a total acceleration is a g sine theta, which is the very famous result. Okay, so this is my solution. Okay, hope you like. Thank you very much.